that's the formula we need to use. The initial, first we need to calculate the time. The time is when you reach the highest point, it will become 0 meter per second. So the time will be 3 meter per second divided by 9.8 meter per second square, right? And then you just need to plug in everything. You have a 3 times that's the time plus 1/2. Acceleration is negative 9.8. Then 3 over 9.8 square. Okay. So this question, you understand the? And then if you calculate, it's 459 meter. So it's D 46 centimeter. So right now you have better understanding for the first part of physics. Remember at that time I told you there is an easier way to calculate this. Is because it's linear. From the bottom with velocity 0 until here. If the acceleration is constant, the average velocity will be the initial velocity plus the final velocity divided by 2, the average of these 2 points. So this one actually, what you can do is the average of velocity times the time, where the average velocity will be the initial velocity 3 plus the final velocity 0 divided by 2 times the time, which is 3 meter per second divided by 9 meter per second square. So this way, you see the calculation is a lot easier than here. You just need to understand here. If you have an initial velocity, a final velocity, and in this process, the acceleration is constant. Let's say it's a constant. You can get the initial, final, the average will be plus divided by 2. That's something extra. If you have time, you can remember this, memorize this. Okay, and then number 7. 6 kilogram object moving 5 meter per second. 6 meter per second. 2, and it got stick to this another object, and after the collision, the whole thing moved 2 meter per second in the in a direction opposite to the initial direction. Collision is moving in a direction opposite to the initial, to move like this. Okay. It's opposite. Determine the speed of the 2 kilogram object before the collision. So let's write down the initial in the after collision. The initial, the 6 kilogram, is 5 meters per second. The 2 kilogram, we don't know. That's the one we need to calculate. After 6 kilogram, 2 kilogram, they get stick to each other and get a velocity of -2 meters per second, right? That's all the information we have. And then if we put everything together, 6 kilogram times 5 plus 2 times the velocity should be equal to 6 plus 2, because they stick to each other, times -2. And 2 velocity will be -8 times 2 minus 5, 6 is 30, and it's -46. So if you calculate velocity, it will be -23. So, but the question is asking you the speed, so you take out the direction, it's 23. Eight. 3 kilogram mass slide on east and west. 3 kilogram, velocity of 5 meters per second to the east. So when it undergoes a one-dimensional inelastic collision with a 2 kilogram mass that has an initial velocity 2 meters per second west. After the collision, this 3 kilogram mass has a velocity of 1 meter per second east. So after collision, how much kinetic energy does the two mass system lose during the collision? Okay. The initial, and then the final. The initial 3 kilogram has 5 meters per second. The 2 kilogram got -2 meters per second because it's moving to the west. And then final, the 3 kilogram got 1 meter per second. 2 kilogram, we don't know. That's the thing we need to calculate. So 3 times 5, 2 times -2 should be equal to 3 times 2 plus 2 times the velocity, right? And here is 15 minus 4 is equal to 3 plus 2 velocity. So 2 velocity is equal to, here is 11 minus 3, that will be 8. So the velocity is 4 meters per second. We know the velocity in the end here. So from those calculation, we know here is 4. Okay? And then the question is ask you, what's the loss of the energy, kinetic energy? We need to calculate the initial kinetic energy and the final kinetic energy. The initial is 1/2 times 3 times 5 squared plus 1/2 times 2 times -2 squared. And in the end is